Hi, I'm Rob, N1NUG. Today we're going to take a look at this Yaesu FTM-3200D and see if we can fix it. Now before I get started with the video, I want to let you guys know that I'm not an expert. That'll be abundantly clear as you watch through this video. So I'm offering this up just for entertainment value only. Before I dig in and take anything apart, I'm going to give you guys a little bit of backstory because it's going to be important as we go through the troubleshooting process. Now, this radio was actually hooked up in my garage and working just fine a few weeks ago. Turns out this power supply back here that it was hooked up to when it was in the garage actually had a problem as well. If you want to see the details on that repair, I'll leave a link to the video I made in the description below and somewhere up here. Now, once I got the power supply fixed, I hooked the radio back up to it and found that the radio wouldn't turn on, despite the fact that the power supply was okay. I put the radio on another power supply I have that I know works because I have another radio hooked up to it, and it still wouldn't turn on. Now, it's also conceivably possible that a nearby lightning strike was the source of the problem. It might have caused the power supply to fail. It might have caused the power surge into the radio. I really don't know at this point. All I know is that the power supply did fail, and it's a strong possibility that that contributed to whatever's wrong with the radio. So I'll keep that all kind of in the back of my mind as I start to dig in and see if I can figure out what's wrong here. Before I do any troubleshooting at the radio level, I just want to verify that the power source is good. As you can see in the meter, we're getting 13.73 volts, so the power supply is working and producing the voltage that we should have. So next, let's take some measurements from the power connection on the radio, just to check for opens or shorts. Now, I'm fairly certain we don't have any shorts because the fuses in this power cable are not blown. If there was a dead short here, the power would go right through and blow one or maybe both of these fuses. But I want to probe these pins anyway just to see what we get. As I suspected, we don't have a dead short. We've got some kind of resistance value there creeping up. The meter is going through whatever active circuitry might be in there that it can kind of activate and giving us kind of a changing resistance value. With the connections reversed, you can see we're getting the same thing. Now, because we're not seeing a dead short or an open, I think the next thing I'll do is pull the cover off and take a look at the circuitry in here and see if there's any obvious signs of damage. Looks like there's just a few screws that hold the cover on, one on each side and one on the top. Now, before I dig into the radio itself, I wanted to take a look and see if I could find a schematic or service manual, and I did. In fact, I'll leave a link to where I found it down below in case you're interested. Anyway, I'm going to scroll down first and we're going to take a look at the block diagram for the radio. This will give us some clues as to how the radio works and maybe give us some areas that we can look into. So the first place I'm going to look is at the power supply chain. If we look over here in this part of the block diagram, we can see that the 13.8 volts comes in here and goes through these circuit blocks. I'll start off by tracing the 13.8 volts from right where it enters the radio and then passes through these circuits. Now, taking a look at the upper left portion of the schematic, and in particular these 2 points, this is where power is entering the radio. 13.8 volts is coming in here, and this is the 0 volt or return line, or I guess we could call it ground. I'll check and make sure that the voltage is passing through these ferrite beads, and then I'll check diode 1003. This is our protection diode and is supposed to help against connecting the radio up backwards or power surges possibly. And then there's a few capacitors here as well. If these all check out good, I'll continue tracing the voltage through the circuit to see if we can figure out where the fault is. I did a quick visual inspection and don't see any obvious signs of any damaged components. So I think I'm going to start by just checking some voltages and see what we get. So I'll start right at the beginning where power comes into the radio. Now I can't check directly on the wire here since the insulation comes right down to the circuit board and my probe tip isn't sharp enough to get through there. But I can tell from the circuit board layout this pin of this ferrite bead is connected directly to the wire, so if I probe here, we should get a good reading. So we got 13.8 volts there, Let's keep making our way down the circuit and see what we got. Now, just for fun, we'll check the other side of the ferrite bead just to make sure that's not open. And as you can see, it's not. So this side of the ferrite bead is connected directly to the cathode of D1003 through a copper pore on the circuit board. So I wouldn't expect there to be any issues, but we'll check this anyway, and that looks good. The anode of this capacitor is also connected to that pore, so I wouldn't expect there to be any issue there, and there's not. So I think the next thing we'll do is check continuity across this ferrite bead to see if there's voltage over here, and it looks like there is. So at this point, I think we can consider all of these components, including D1003, as good. It looks like we've got voltage that goes beyond this ferrite bead and produces the B plus voltage that you can see here. So I think I need to start looking at some of the other blocks from the block diagram. Now, unlike an old school radio that has sort of a mechanical switch that actually breaks the power connection to the radio, this one is just sort of a momentary switch. And what that means is that even when the radio is off, there are 1 or 2 or 3 circuits in here that are always energized and sort of waiting for that power button to be pushed so that the rest of the radio will turn on. So I think the next thing that I want to check and see is if that constant voltage is there and the power switch is working and doing what it's supposed to do to get that voltage to the CPU and command it to turn on. Now we're taking a look at the schematic for the front panel of the radio. And in particular, we're going to take a look at this lower right corner where the power switch is located. So as you can see, the symbol depicts a switch, and we know that it's a momentary switch. So when the switch is pushed in, what ends up happening is VCC is connected to this line right here. And if we follow this along through the schematic, there's a pull-up resistor here, and then it ends up at pin 6 on the main connector between the front panel and the main circuit board. And you can see here that the signal name is power_switch_data. If we go back to the schematic for the main circuit board and look down here in the lower part where the connector comes in, we can see that on pin 27 of the main board connector is where we have power_switch_data. Now in particular, if we look at this signal, we can see here it's kind of jumbled up text, but it has a test point connected to the circuit, test point 1033. So that means somewhere on the board we should be able to find an open pad that we can probe with the meter. Now also on this connector we have VCC on pin 25 connected to test point 1031. So what I want to check now is first I want to probe this test point 1031 and see if we have VCC. This is the power that should always be active whether the radio is turned on or not. And then we can probe the test point on the power switch data line to see if we get VCC at this test point when the power switch is depressed. If we do, that'll tell us that the power switch and its associated circuitry on the front panel board are good, and we can focus our efforts on the main board. We're now looking at the page in the service manual that shows the board layout for the main board. Well, the side that we can see anyway, side A. So if we look at the lower portion of the layout, we can see the connector here that is ultimately connected to a ribbon cable that goes off to the front panel. Wherever one of these test points is depicted, we should have an open pad on the circuit board that we can probe and look for voltages on. So over here on test point 1031, this is the VCC test point. I'm going to probe here and see if we have voltage. And then over here at test point 1033, I'm going to put the meter on that one and then press in the power button and see if we get voltage while the power button is depressed. And again, just to flip back to the schematic, those two test points correlate to the power switch data line, test point 1033, and the VCC line, test point 1031. So after looking the circuit board over, I've determined that this test point right here, this gold pad, is test point 1031. So if we check this out, we should get some kind of voltage here. And as you can see, we've got 3.24, or what I'll call 3.3 volts. So now if we go to test point 1033, which is over here, and we probe that, it should be 0 volts right now. And of course it is. Now if I push in on the power switch, it should go to 3.24 volts, or 3.3. And as you can see, it is. So that test actually tells us two things. The first is that the power switch is working fine and doing what it's supposed to do. The second thing it tells us is that the constant VCC power that we need to sort of wake the radio up is present and accounted for. Now unfortunately, it also starts to point towards the main CPU in this radio being the problem. And the reason I say that is because what's supposed to happen when the power button is pressed is that one of the pins on the CPU is supposed to be brought up to the VCC voltage, which in turn should wake up the CPU and tell the rest of the radio to turn on. But if we think back to the block diagram, there's a few more circuits that are in that sort of always active situation that we need to kind of look at as well, just to rule those out as a problem, because even if the CPU is being commanded to turn on, if some of those other circuits are not present, say another voltage, the CPU won't fully turn on and the rest of the radio won't be able to turn on. Now hopefully that's the case and the main CPU isn't the problem, but let's dig a little deeper and see if we can determine one way or the other what's going on. Taking another look at the block diagram here, we can see basically what we've done is we've now ruled out this block as being a problem and this block as being a problem, as well as the power switch. So I think I want to take a look at this block next, because if this one isn't functioning or open, it looks like it interrupts the flow of power between the main power input and these other sort of step-down voltage regulators. So looking back at the schematic again, Q1003 is sort of right here, right below all the protection circuitry we already checked. If we take a closer look at this, we can see B+ comes in over here on this pin. We've got a couple of what I'll assume are biasing resistors over here, and then it looks like the output power comes out of these pins and goes off to the rest of the radio. I don't see any test points labeled in the schematic around here, so we're going to have to find another spot to probe. Now if we take a look over here, C1014 is a 16-volt electrolytic cap that is tied directly to the output of Q1003. Now these electrolytic caps are usually bigger parts, probably mounted on the top side of the board, and should have a pin that we can probe with the meter. If we go back over to the board layout and look around, we can see that C1014 is right here on the top of the board, and we should be able to probe this pin right here and get some kind of a voltage out of it. So back over here at the radio, C1014 is located right here. Let's probe that pin and see what we get. And it looks like we're getting 0 on the meter. So I think what we need to do now is pull the board out of the radio, flip it over, and have a look at the other side and see if we can see what's going on with Q1003. 14 screws and one standoff in the middle of the board are holding this thing down to the chassis. Now some of you may know that I used to work at a company that made components for the space industry, and even for those boards we didn't put as many mounting holes in, so kudos to Yaesu for a real rugged design here. 15 screws in a standoff. I missed one. You guys probably saw it though. So now what I need to do is very carefully remove this ribbon cable from this connector. Now at first I thought this was one of those ZIF connectors, or zero insertion force, with a latch on it, but I don't see any latching mechanism. It looks like this thing is just in there. So I'm just going to kind of firmly but gently wiggle that thing out. Well, maybe not as gently as I could have, but it's out of there now. The next thing I think I'll do is disconnect this connector for the fan. And then next, it looks like the SO239 is pretty well connected to the chassis. So hopefully we can just remove these two screws and then the board should lift out of here. Actually, now that I think about it, I think the only way to get this out is to unsolder this SO239. There's no way we can get the board out without doing that. I didn't end up having the camera running, but I was able to get the connector unsoldered. Now to get the solder melted, I tried using my usual soldering station, but I couldn't get things hot enough. So I ended up bringing in the big guns here, literally. This is actually my dad's old Weller soldering gun. Now if you recall, the connector was in here and soldered just to the center pin and this lug over here that's connected to the outer body of the connector. And the center pin came unsoldered fairly easily. I was able to get the solder melted and use my solder sucker to kind of get that out most of the way. And then on the side over here, I just had to hold this gun on here for a couple of minutes to get it hot enough to get that solder to melt. Once that was the case, it was obviously too hot to grab with my fingers, so I used the little screwdriver that I have here, stuck it in the center part of the connector, and was able to kind of wiggle it out of the radio once the solder was hot on both pads. But now that that's out of the way, we should be able to lift this board out of here. So I've got the board out of the radio, and I'm taking a look at the secondary side now, trying to figure out where to probe, but I was taking a closer look at the circuit in the schematic, and I think I figured something out about the way this thing works that points to the main microprocessor as being the problem. Let's head back over to the schematic and I'll explain. So we're back looking at the schematic, and in particular Q103 is the part that we're focusing on. Now when I originally probed this, I probed sort of the output pin that was tied to C1014, and we found no output, no voltage here. Well, now that I look a little closer at the schematic, I think that's the way it's supposed to work, just based on some of these signal names. You know, of course we've got B plus up here. We've been talking about that throughout the video. But down here on the output side of this FET, we've got SWB plus. I think what that means is switched B plus, and this is the switch that's turning it on and off. So I decided to trace the gate signal to see if I could figure out what was triggering this to turn on. So if we look here, there's sort of a transistor here. This is probably a current amplifier or something to bring the power up enough to drive this thing. And you can see that its bias pin is triggered by a signal called reg_SW, or regulator switch maybe. If we further trace this down, it goes into this bus wire, which if we zoom out and follow the bus wire, that finds itself at the microprocessor here. And if I zoom in over here, we can see that that is coming out onto pin 87. Here it is, reg_SW. So I think what's happening here is that when the power button is pressed, it triggers the pin over here, wherever it was, to turn the microprocessor on. And when the microprocessor is turned on, it is programmed in turn to turn this pin on and produce a voltage here, which in turn goes up back here to that transistor that's driving Q1003, turns this on, this drives this, and then this in turn turns on all of the other voltage regulators inside the radio. So looking back at the block diagram, here's the block for Q1003. You can see it's right in line with everything else. If this doesn't turn on, power isn't going to flow into these other regulators, so the radio is just not going to turn on. So long story short, we're pretty much mostly screwed. And why I say mostly is because the microprocessor on this board is actually removable. There's actually a little connector in here. You can pull this right off. That's why this foam block is kind of on here, so you can grab it and take it off. Now, if I had another one, I could just pop it on there and give it a try and see what happens. I'm guessing the only place you could get something like this is either from another parts radio that's got some other catastrophic problem, or maybe I could try to buy one from Yaesu. I suppose I could try and give them a phone call, see if they sell that and what they would charge for it. But my guess is they're going to charge more for this than it would be worth to buy it. So this is probably going to now be a parts radio. But I've got one more thing to try before I totally give up. I think what I want to try and do is see if I can trick the voltage regulators into turning on to see if the rest of the radio wakes up. At this point, we don't have anything to lose since the radio doesn't work anyway, so what the hell, we'll give it a try. So luckily Yaesu made this ribbon cable long enough so that it kind of unfolded, and I'm able to kind of keep it plugged into the board so that I can have it flipped over and see the secondary side. Now the circuitry in here is so small and my camera's really just not going to focus on it. So I'm going to apologize in advance that you guys aren't going to really be able to get a good look at to what's going on here, but I'll give you the best look that I can. What I want to do now is find a point on this side of the board that's got 3.3 volts, and I should have it on this side of this cap right here. And hopefully you can see in the meter, we do. So what I think I can do now is run a jumper wire from here to the bias pin on this little transistor here. And that should trigger this to turn on or go up in flames. I guess we'll find out in a minute. Okay, let's see what we can do. Where's my pin? Oh, I heard it turn on. Did you guys hear it? So at this point in the video, there's no video because the stupid camera decided it wasn't going to record the next bit of what I did, which may have arguably been the most interesting bit. Now, I suppose I could try and recreate it here, but I'm too lazy to do that, so I'm just going to tell you what I did. Basically, I held the jumper wire on the radio with one hand after getting everything positioned, and then I tried to turn the radio on with the other hand, and nothing happened. The radio didn't turn on, no fire came out of it, nothing. So at that point, I put the jumper wire down and was thinking about my next steps, and I decided to just hit the power button on the radio, and it actually turned on. And when I say it turned on, the display lit up, and it showed a repeater frequency that was previously programmed in, so it even had its memory. And then it started beeping like crazy, like one loud, long, continuous beep. And it was about 11:30 at night. Everybody else was sleeping. So I quickly cut the power to the power supply so I wouldn't get the dogs barking and wake everyone else up. So at that point, I turned the volume back down on the radio, tried to turn it on again, and nothing happened. I tried the jumper wire again, and then the radio, nothing. I've tried for an hour and couldn't get anything to happen with the radio. I guess the CPU is scrambled, although I'm not really sure. There's maybe potential life in here. It could be just a bad solder joint somewhere, and I may have flexed the circuit board just the right way, and it made contact for a little while. I really don't know. But at this point, I'm leaning towards the CPU being bad. So I think I'm just going to put this thing back together, put it on the shelf, call it a parts radio, and see if another one comes along that has a different problem, and I can make one good radio out of two. Now I know we didn't fix anything in this video, but hopefully you enjoyed it anyway. I know I learned a little bit myself by going through the circuit and trying to figure out how this radio worked. It was kind of fun, even though there's really nothing to show for it except this video. Now, if you did like the video and you made it this far, a thumbs up would be greatly appreciated. Thanks for watching.